In this video, we're going to talk about solving an exponential equation using logarithms. And one thing I want to point out, I've done it in other videos, but I'm not going to do it in this one. One way of doing this with the graphing calculator is put this in as a graph, put this in as a graph, and find where they intersect. Now be sure when you do, you put the exponents in parentheses, but that'd be a good way of checking the answer that we're about to get. Now I'm going to go through the algebraic solution so we can see how to do this with logs. Alright, so first thing we want to do, when possible, we would like to isolate the exponential piece. So we typically divide by any constant that's out front. Well, both of them have constants out front, so we're not going to be able to get rid of it, but we probably can get rid of one of them. So let's divide both sides by 2. It will at least make our work a little bit easier, and that's going to reduce down to 4 times 3 to the x plus 1 equals 5 to the 2x minus 1. Now, when I have something like this, I think it's a little easier to think of taking log of both sides as opposed to rewriting to a logarithm. But whatever you decide to do is going to work. So what I'm going to do at this point is I'm going to take log of both sides. Now, what tells me I need to take log of both sides is I'm trying to solve for a variable and an exponent. That's when you need logs. Now, on the right-hand side, now we're going to use that property of logs that allows us to pull that exponent out front. So I'm going to pull the 2x minus 1 out front times log of 5. Now here's where it gets, you got to be a little careful. I can't do that yet on the left-hand side because 4 is not being raised to the x plus 1. What I can do is I have multiplication. I can use my product to some property of logarithms. So I can rewrite this as log of 4 plus log of 3 raised to the x plus 1. Because now I can pull that exponent out front. So I have log of 4, which is just a constant, plus x plus 1. And notice I am putting the exponents in parentheses. That's going to be important because it's this whole quantity multiplied by log of 3. And same thing over here, the whole quantity 2x minus 1 being multiplied by log of 5. Because what I'm going to do next is actually distribute the log pieces over the parentheses. So on the left-hand side I have log of 4 plus x times log of 3 plus log of 3. Now when I distribute the log of 5, I have 2x log of 5 minus log of 5. Okay, so I know it looks a little bit messy, but it's not as bad as it seems. What you need to do is just think of log of 4 and log of 3 and log of 5. They're just numbers, but they're exact numbers. If we calculate them as decimals in the calculator, we lose our some of our exact value. So what I'm going to do next, notice I have two x's in here. I want to get all the terms with x in it on the same side, all the terms without x on the other side. So I'm going to take this term and move it over to that side by subtraction. So I'm going to subtract x log 3 off of both sides, so minus x log 3. And I'm going to move this to this side by adding log 5 to both sides. We are getting really close to being done here. So let's see what we got when we clean this up. Gone and gone. So on the left-hand side, I have log of 4 plus log of 3 plus log of 5. On the right-hand side, I've got 2x log 5 minus x log 3. Okay, now the whole reason I did that is because now on that right hand side I can factor an x out because I've got an x in each term. So this equals x times 2 log of 5 minus log of 3 equals our whole right hand side. Log 4 plus log 3 plus log 5. Alright. Oh, jeez. I forgot to write my 3. Okay. So, next thing I'm going to do is I'm going to divide, and I'm going to show you a couple different forms we can put this final answer in. It's kind of cool that we can do using properties of logs. So what I have is log of 4 plus log of 3 plus log of 5 over 2 log of 5 minus log of 3 is equal to x. That is a nice exact answer. Now, there's a couple other forms that we can actually put this answer in, so let me give myself a little bit more room. And that's using properties of logs. On top, notice I have logs that are being added. That means I could rewrite them as a product. So I could rewrite it as log of 4 times 3 times 5. And then bottom, I can put this back in the exponent. So that would be log of 25, because I got 5 squared, minus log of 3 equals our x. Now let's just simplify that top. So we have log of 12 times 5, which is 60. And we can actually do something similar on bottom, because now we have a difference of logs. I can rewrite that as log of 25 over 3. Now that's as far as we can go. You may be tempted to cancel out the logs. You can't do that, or divide the 60 by 20. You can't do that. But this was a little bit more simplified way of writing our answer than what we had up here. And that's our nice exact answer algebraically. Again, we could check it with a graphing calculator, as we spoke about at the beginning of the video. But this is how we would do it with logs. Now we have an exact answer, which if we need to use in another formula, we've lost no accuracy.